这个影片要介绍的是化学品喷溅处理。亚泥花莲厂使用到的健康危害化学品有部分是强酸或强碱，例如硫酸、盐酸、片碱或称叶碱，还有氨水、乙二胺等。万一不慎被喷溅，要如何正确处理呢？其实，从化学品的管理来看，应该要从危害辨识与风险评估、工程控制与行政管理、个人防护具、紧急应变，以及教育训练与资讯管理等着手。而这个篇幅我们要介绍的是紧急应变的部分。当然，预防事故发生才是首要。化学品管理及个人防护具佩戴及教育训练做确实了，是可以避免人员遭受实际的危害的。不过，万一有意外发生，及时的急救抢救可以将伤害降低。我们就来介绍，万一被化学品喷溅了，如何紧急应变。首先，我们要先了解遭受化学物质喷溅造成化学灼伤的3个关键阶段。最初10秒的接触阶段，化学品与生物组织接触的前10秒，皮肤和眼睛表层尚能抵抗渗透，这是最关键的几秒钟。如果在10秒内就得到妥善处理，就可以大大减低伤害，不会造成太大的健康危害。如果是10秒至1分钟的渗透阶段，这时候化学品开始渗透，但造成的伤害通常仍可逆。若能在1分钟内处理，还是能有效降低伤害的。再来，若是1分钟后的化学反应阶段，这个阶段是已经形成伤害，能快速处置，是黄金准则。第一，药物是除污。什么是除污呢？除污简单的说，就是把身体上的污染物、化学物质尽可能移除，减少跟身体的接触。当化学物质溅渗的事件发生时，第一要务就是除污，要迅速离开危险区域，将受到化学物质污染的衣物及隐形眼镜脱除，并吸附身上的残液，然后再冲洗。如何冲洗呢？如果没有迪辅林，冲水至少15分钟。评估需要送医处理，则携带安全资料表前往医院。有迪辅林的话，就尽快用迪辅林冲洗。它对强酸、强碱、氢化物、氧化物、还原剂等都适用。迪辅林是利用高渗透压原理，具有两性耦合作用，对酸碱都可以使用。关于迪辅林，我们参考官网的介绍，迪辅林适合非氢负酸之化学品，对于强酸、强碱、氢化物、氧化物、还原剂、溶剂等都适合使用。此产品是利用高渗透压原理，具有两性耦合作用，能以多价位的方式阻止并拔除化学物质，改进了冲洗的局限性及对组织伤害小。另外一个产品六氟林是针对氢负酸及氟酸盐类。氢负酸具有双重威胁，氢离子酸性、腐蚀性以及麩离子的毒性。麩离子能深入渗透，破坏生物性平衡，甚至可能导致心脏骤停。六氟林能透过高渗透压和吸附能力，将氢离子和麩离子从组织内带出，并饱和麩离子，有效阻止其腐蚀性和毒性作用。而迪辅林无法彻底解氢负酸及其衍生物的问题，对氢负酸的效果非常受限。这两种溶液有不同的功用，而它们的共同特点就是皆为2级医疗器材，可安全用于健康和受伤的眼睛及皮肤组织。它们均无刺激性、无毒、非致敏性，且经过灭菌，能减少失温风险，舒缓疼痛，简化急救程序。迪辅林相比于清水冲洗有何优势呢？传统清水冲洗难以有效中和化学品，而迪辅林采用高渗透压原理，其渗透压高于血液和生理盐水，能产生逆渗透压效应，主动将已渗透进入组织的化学物质，如酸碱、氧化剂、还原剂、溶剂、可合剂和烷化剂等， 从深层组织中抽出并中和，从而避免或减轻组织损伤。多项实际案例显示，迪福林能显著降低化学品灼伤的程度，甚至在某些情况下避免受伤，并缩短恢复时间。接下来，我们来观看两段官方的介绍。
Ranbir and Ranveer are both getting ready for the monthly maintenance work in the factory. Ranbir wears a diphoterene belt assigned to him. Ranveer gets ready quickly, but he doesn't have a diphoterene belt. Ranbir and Ranveer are both busy getting their work done, which involves testing valves and pipes for leaks and general maintenance. Oh no! The concentrated chemical has splashed all over Ranveer and Ranveer's face.
Hi, I'm Ranbir. How did this happen? I was working on fixing a leak on a pipe when the chemical suddenly splashed on my face and eyes through a joint. I too had a small accident, splashed chemical all over my face when I was working from a leaky pipe. But how are you so relaxed then? I used diphoterene immediately as per protocol in my factory. It gave me instant relief from the pain and the burning. And factory officials have sent me here for a checkup just to be sure.
Next.
Doctor, please do something. My skin is itching and burning. I'm in a lot of pain.
Oh, chemical burns. Wait, I'll wash it off with diphoterene. Ranbir, please go to the waiting room. I'm going to check you next. But you don't look like you would need further treatment. Ranbir, you have to wait and see our eye specialist.
But I used a lot of water for almost 30 minutes.
Water works on all chemical splashes. Even if you don't know which chemical you've been splashed with, water will always help. Now in your case, water has helped, but it hasn't been used quickly enough. As a result, it could not remove outside of your eye 100% of the chemical.
Oh no, so is the eye permanently damaged?
No. It looks like it will probably need a surgery, which may cost over 2 lakhs, and you will not go back to work for another 2 weeks at least. My experience over 28 years and my recent use of diphoterene solution over 200 cases in comparison to rinsing with water show a clear improvement. Number of days of work loss, cost of hospitalization, pain relief. Sulfuric acid, caustic soda, hydrogen peroxide, dimethyl sulfate, hydrochloric acid. Diphoterene is the universal first aid solution that can prevent all types of chemical burns irrespective of the concentration of the chemical.
Hello. Today we will find out how and why hypertonic decontamination improves chemical risk management. Why should you use a hypertonic solution to rinse your eyes? In fact, the key term in the answer is osmotic concentration. You've probably already heard about the drinks specially designed for athletes, the so-called isotonic drinks. They contain ions, or as athletes say, electrolytes. These drinks restore these electrolytes to our bodies after physical effort. The ions, or molecules, move through the liquid and make contact with the container. They apply pressure to the container. This is the osmotic pressure, otherwise known as osmotic concentration or osmolarity. Our body also contains ions and molecules. It therefore also has an osmotic pressure. If a liquid has the same osmolarity as our body, it is isotonic. If the osmolarity is lower, the liquid is hypotonic. And if it is higher, it is hypertonic. What does this characteristic mean for a liquid? Let's do an experiment. I will fill a glass with tap water. There are very few ions, so the osmolarity is low. Next to it, I will fill another glass with seawater. This water contains sodium chloride. Of course, it contains many more ions, sodium and chloride ions. Therefore, the osmotic concentration is much higher. Then I connect the two glasses with a membrane through which the liquid can pass. What will happen? The answer is quite simple. Nature balances the osmolarity in the two glasses. The liquid moves from the glass with the lower osmolarity to the glass with a higher osmolarity. This process continues until a balance is reached. This phenomenon is also used to produce tap water from seawater. For desalination, reverse osmolarity is used with special membranes. Let's get back to the chemical contamination in the eye. Our bodies have an osmotic concentration of about 0.4 osmoles per kilogram. Now consider a sodium hydroxide solution. Sodium hydroxide is rich in sodium and hydroxide ions. Depending on the concentration, the osmolarity varies between 1.8 and 2 osmoles per kilogram. Unfortunately, I get splashed with this chemical in my eye. The concentration of ions in the contaminated eye increases, so the osmolarity rises to about 1.4 osmoles per kilogram. I start to rinse as quickly as possible and use the safety shower with tap water. However, the osmolarity of tap water is quite low, about 0.1 osmoles per kilogram. So I put liquids together that have a very different osmolarity. Remember the two-glass experiment? Even in the case of this accident, nature will balance the osmolarity of the two liquids. But here the difference in osmotic concentration between the eye and the water is immense. 1.4 versus 0.1. Many water molecules enter the cells of the eye. Because there is little space to accommodate the water, the cells of the eye will eventually burst. This is what doctors call osmotic shock. To support this, we will show a video. Ophthalmologists incubated endothelial cells from the eye at 0.8 osmoles per kilogram and then put them in contact with tap water. You can see how quickly these cells burst. You can also observe this phenomenon when you take a shower or spend a long time in the pool. Your fingers will get soft and wrinkled. For your skin, this is not as problematic. Cell regeneration is quite fast. However, our eye cells are much more sensitive and can suffer irreversible damage. This is why ophthalmologists recommend, after a chemical accident to the eye, to rinse at least with an isotonic solution, or preferably with a slightly hypertonic solution. This way your eyes will return to normal more smoothly, and you will avoid an osmotic shock. We hope this explanation is helpful. And of course, we remain at your disposal for any questions concerning prevention and safety around chemicals in your workplace or at home. Thank you, and see you soon.